All right, so let's get started. So today's going to be mostly demos, and I'll be perfectly honest. I thought I had more slides. I checked my slides this morning, and I only have like 5. Uh, so I don't have. So I'll fill up the rest of the time with demos. I have one planned demo, and then we'll have some extra time. So if there's anything you want to see demoed, let me know. Otherwise, I'm just going to go through a whole bunch of different demos and just show you a whole bunch of different stuff. Yeah, somebody's making a bunch of freaking noise outside. Don't they know we have streaming to do? I swear I just need a soundproof booth. But anyway, it's going to be too nice a days to leave the windows closed. I guess that's the bigger problem. So let's give an overview of authentication, which you have to do for this final homework. Yeah, it's just an angry 116 student. It's probably Priest outside my door. That's why he wasn't in chat, Muffin Man. So an overview of authentication. We've all seen it from the user side, and now we're looking at this from the other side, from the system side, from the web app side. There are 2 steps in this. A user has to register. They're going to send you their username and password, and usually we duplicate the password. We say type your password twice, just for a little extra verification to know that they didn't mistype their password when they entered it. I'm just going to say username and password, not password 1, password 2. And also for your homework, if you don't want to do 2 password fields, I'm fine with that. If you do, I'm fine with that too. So username and password. This is where we're going to validate the password strength if you're doing the bonus for the homework. This is where you would check the password, which probably shouldn't even be a bonus. I should have had that as a regular. That should have just been objective 4, and then the bonus should have been something harder. But you know what? Just like this conversation, we're all tired, so I went a little easy on that one. But this is where you would validate the password strength. So if you have the common requirements, 8 characters, 1 lowercase letter, 1 uppercase letter, a number, and a special character, which as we saw last time, isn't very good, isn't going to produce very good passwords. If anybody's just doing the minimum, their stored hash of their password is not very secure. But this is where you do that validation, whatever your rules want to be. This is where you check it. On registration and on the server, there are password validators that run on the front end. But as we know by now, is hopefully, I don't feel like I say enough in this course. This semester, I feel like I haven't said it enough. But you can't trust anything your user does. Never, ever, ever trust your user. Because if you put your password validation on the front end, the user can just rip all your validation out and send whatever password they want. Maybe that'll make a good demo. We could demo that, actually. So you can't trust your front end. You can't trust your user. You can't do password validation on the front end, or rather you can do password validation on the front end. Many, many sites do, but you have to also do password validation on the back end, on the server side. So you can do password validation on the front end just strictly as a user convenience. You don't want the user to submit this form and then the server say, hey, you didn't fill out that form right. That doesn't feel good as a user. It's not a good user experience. Instead, we have a front-end validator, so as they're typing, we can say, hey, that password's not strong enough, just so you know, just as a heads up, the server's going to reject that. Server's not going to like this at all. And then they can retype their password. But so don't get confused. Just because you use sites that have front-end validators, you cannot validate password strength on the front end only. That's only as a user convenience. You have to validate on the server. Server gets this password, it's going to say, okay, I like this password. It checks all my criteria. And by the way, of course, implied here, every site is handling your plain text password because they're checking it for strength on the server side like they're supposed to. They're handling your plain text password at this point. And then after they're handling your plain text password, they like it, they inspect it, passes inspection. They're going to append a random salt to the end of the password. And then they're going to hash that password and store a hash of the password along with that random salt, where the salt is a randomly generated string that's generated on a per user basis or even a per password basis. If you change your password, you're going to get a different salt. So that's what's actually being stored in the database, is the salted hash of your password along with the salt itself. When somebody wants to authenticate, and your username, of course. And then when somebody wants to authenticate, somebody wants to log into your site, wants to use your app as their user, using their user account, they're going to send you their username and password again. Now, ideally, this is going to match the username and password from registration. They're going to log in. But if it doesn't match a username and password that you have on file in the database, then they're not going to be authenticated. That much we're all familiar with. How do we do that? Well, we're going to take this username. We're going to take that to our database and do a lookup. Say, hey, database, I need the account information for this user. That's going to give us the salt and the salted hash for that user. We're going to take the password that they gave us. We're going to append the salt to the end of the password. We're going to hash that password with the salt. And we're going to check if that hash exactly matches the hash that we retrieved from the database. If that hash is absolutely exact, then they're in. We say, okay, you're authenticated. Congratulations, you are who you say you were. Tell Jesse that email was a joke. No way, I'm doing that now. And they are who they say they are, so we're going to treat this user as username. Like they've officially logged in as themselves. We're going to be happy with that. Why are you here? Seriously, Muffin Man and Priest. I'd fight if you want to learn some 312, but, ask 312 questions and say 312 things. So, at least during the lecture portion. So, there's one other piece to this puzzle, is authentication tokens. So that's fine. What we just talked about is fine. If we want to authenticate a form submission, and that's about it. So with this setup, every time a user wants to authenticate as themselves, they have to provide a username and password. So now what we have is a situation where every action that a user takes that needs to be authenticated needs to have this username and password associated with it. So now every time somebody wants to change their profile picture, wants to tweet something out, anytime they want to send a DM, every time they take any action on your app, you're going to be like, hey, by the way, I need your username and password so I can authenticate you. Of course, we're not going to do this. Our site will have exactly 0 users if we do this, because nobody's going to do that. That's ridiculous. Nobody's going to do that, and that's not what we're used to on the internet. You punch in your username and password once. You register, you punch in your username and password once, I guess twice. Once for registration, once for login. And then you're just logged in, forever. A lot of apps these days, I know I'll register, punch in my username and password to log in, and then by the time that session is expired, for whatever reason, I forgot my password by then. It can be years down the road before you have to produce your username and password again. You've probably had similar experiences. You log into an app once. That app does not want to ask you for your username and password ever again for user experience reasons, because once they ask you for your username and password again, that's giving you an exit point. That's giving you an option to say, you know what, I'm done with this site anyway. I'm not going to take this extra step. I was only here because I was addicted to your content. If you're going to ask me to remember a password or do the forgot password link and check my email and go through all this stuff, you know what, I'm just not doing it. Sites don't want that to happen, so they're going to never ask you for your username and password again if they can help it. There are sites that don't do this, notably, you know what, I shouldn't even say that. But I was going to say notably, I'll say it anyway, but I'll say it with a different tone. UB Learns and MyUB, they're going to log you out for the same reason that banks will log you out too. Notice banks, the session only lasts a very short amount of time. That's when the data is very very sensitive. Your educational records, your financial information, those systems protect some very confidential information. So they don't want you leaving these sessions open for too long. They're gonna have that session expire, and they're gonna make you re-authenticate fairly often. They can also get away with it because what are you gonna do? Just not look at your money anymore? Like not log into your bank? It's not gonna happen. Do you think the password payment information store in browser is safe? In the browser, it's safe enough for me to trust it. Once you do the browser that's also sharing across all your devices, that's less safe because now your passwords have to be flying through the internet in some way. Like that gets a little more spotty, especially if it's backed up in their database. Now you have a database with a lot of passwords. Presumably they're salting and hashing like they're supposed to, but I don't know. It's just one more point of failure, one more thing that can go wrong. But local storage in the browser, it's safe enough that I trust it for what it's worth. I like having the browser remember my password so I don't. But if somebody gets a hold of my device, then they have all my passwords. But honestly, if somebody has access to your physical device, they have tons, like they have so many ways to attack you anyway. I mean, you're done at that point regardless. Anybody who you know, if you let somebody borrow your laptop, God forbid, they have access to like everything. There's no reason to be. Then don't remember me. There's no reason to be. No, it's hard for me to even say that one. But it's if you're really concerned about security and you want to be secure to the level of even somebody with physical access to your laptop still can't attack you in any way, you have to take a lot of steps to be that secure. If you are, that's fantastic. Like if you don't trust your roommate, maybe you want to be that secure. So if you're at that level, then no, browser storage, password storage is not safe. But if nobody has access to your laptop, then you're already vulnerable to things like that anyway. So to avoid asking for this username and password, we're going to use Authentication Tokens. Or it's something like face recognition. I mean, that's why we're seeing 2FA pop up everywhere. You got to have your password and access to your phone. But even that, it's physical access to some hardware that you have. That's what a lot of security is based on right now. Do you physically possess the hardware that this person owns? Which is pretty secure, especially when we're talking about protecting against bots that are scanning the internet. Like, they have no chance. It's only people that you know who are gonna, or people who physically close to you who are gonna be able to successfully attack you that way because they have to have physical access. All right, so we're gonna use authentication tokens. What are authentication tokens? Well, when somebody logs in, they provide their username and password, and now instead of saying, okay, you are who you are for this specific request, this flashes back to cookies, and we're gonna use cookies here. That request is stateless. HTTP is stateless, so we're going to ask them to provide their username and password on every HTTP request? No. We're going to use cookies here. So when somebody logs in with the username and password, we're going to generate some random, I say random, but you can have a deterministic strategy of generating these tokens. You're going to generate a random appearing token to a third party, and set this token as a cookie. Oh, I don't even say that on this slide, right? Okay, I guess I won't talk about that. I'll adhere to the slide. So we're going to generate a random-ish token with very high entropy. We're going to look at that 2 to the 80 rule of thumb that we talked about last time and generate a token with at least 2 to the 80 bits of entropy. Now, these don't have to be remembered by anybody. So we're gonna fill up that entropy. We're gonna create enough random characters with enough random enough length that we're gonna get at least 2 to the 80. And if you want to go nuts with it and get like 1K bits of entropy with these, go nuts, go ham with it if you want. But at least get 2 to the 80. For your homework assignment, if you have like four length 4 tokens or something like that, that's not secure. But if you have a reasonably long random string, you're gonna get this 2 to the 80 pretty quick. So we're gonna get a very random looking token, something that can't be guessed, something that can't be brute forced, and then associate that token with the user. And by that I mean use your database. In your database, you should have an entry. This username is associated with this token. So store that in a database. If you're using SQL, that's a table. Username and token, that's one of the tables in your database. So you can quickly look up, hey, I have this token. Who is this? Who is this person? So you're going to take that token, do your query, and say, okay, give me the username for this token. And now you can say anybody who possesses this token must be this user. So you're no longer asking them for their password anymore. You're just saying, look, if you can produce this token for me, I'm going to treat you as this person. Because I gave you that token when you authenticated. If you have that token, then I know you've authenticated in the past. Because how else would you get this very random looking token, this high entropy token that nobody could possibly guess, because 2 to the 80 is a stupid high number. There's no way you're going to guess when your odds are 1 over 2 to the 80. It's just not possible. I mean, I shouldn't say not possible, but it's so unlikely that we can consider it as impossible. It's effectively impossible. So if you have that token, we're going to say you must be the person who authenticated, the person that we gave that token to and trusted that token to. But we have a little bit of a problem. Okay, if you have to produce this token, like, why not just ask the user to produce their password? Because we have something that they have to produce every time. They still have to produce this token. Well, with the token, we can do something a bit more user-friendly than passwords. So the nice thing with the token is that the user does not have to remember it. And we don't have to rely on the user remembering it at all, because the server produced it. The server produced this token. The user never has to be aware of this token. I'm sure most of you, if this is the first time you're hearing about authentication tokens, then you've never dealt with these ever. You've never even known they existed. If you have heard of authentication tokens, I think this is common enough that most of you have heard of this and understand the basics of this concept. But until you have, you were using tokens like this on the internet for years and years until you found out that this is a thing. You never have to know about authentication tokens from the user perspective. And that's what we like. We like things being user friendly. We like the user not having to be a part of every technical aspect of how our server works. We don't like that. We want them to just use our site. So how do we do that? How do we actually get the user to produce this token on every single request, ideally, because every request that comes in, we want to know, is this user actually who they say they are? So once a token is generated, what we're going to do, we have a mechanism to do exactly that. We're going to set it as a cookie. We set that token on a cookie, and now that token is coming along with every HTTP request from that user until the cookie expires. Cool. We did it. We did it, everyone. We have a way to identify this user in a secure way for every subsequent HTTP request after they log in. So since the token's set on every subsequent request, when we get a request, we get that token along with the request. We look up our database and say, hey, who's the user? For who did I give this token to? We look up the database, say, oh, your username. And since you have this token, we're going to assume that you are authenticated. So you must actually be this user. And we're going to treat that request as though it came from that specific user. And that's how authentication tokens work. It isn't a security issue to just trust the headers in an HTTP request. Well, nobody should be able to spoof so what this relies on is nobody should be able to spoof those headers because they don't know what the token is. And these tokens, if it's set up properly, we'll actually see an example where it's not, which was a little surprising, is those tokens, the cookie should be set as secure, which doesn't just mean, okay, I put the word secure on it, so it's secure. But from the cookies lecture last Wednesday, that means that cookie, the token cookie, is only going to be sent over HTTPS requests. So it's always going to be encrypted. So nobody can read that header except the client and the server. Those are only the two endpoints can actually read what that header is. So nobody can grab that header out of the Wi-Fi. Nobody can get that token out of the Wi-Fi. And then since that token has so much entropy in it, we're going to trust that if we have a token that matches a token that we did generate, and then store in our database, then we have a reasonable assumption that that user actually did authenticate that. Actually is a legitimate record. Is there 23 Bears? Is there a specific thing you're like? Did I answer that? Is there a specific thing that you're thinking? I don't know if our calculator is even gonna really handle these numbers. But like if you have 2 to the 80, that's how many possible, and this is a minimum. At minimum, you're gonna have this many possible tokens. And let's say you have 8 billion users, 1,000 million billion. So you have this this 1 over, what am I doing here? You have this probability that, I guess I did, I don't know. It's a big number is my point. But I blanked on what math I was actually doing. But if you have 2 to the 80, you have 1 over this odds of somebody just randomly guessing. Oh, yeah, that's what I was doing. You have 1 over this odds of somebody randomly guessing your authentication token. So, well, maybe somebody doesn't care about being you. Maybe they just want to attack anybody. So what they're going to do is generate a random token and then submit a request to the website, and just hope that that is a token that exists in the database. So let's say even you have 8 billion users logged in. Everybody on the planet loves your app and is using your app simultaneously. Everybody is logged in. Literally everybody. Well, now they still have a 1 in this chance. What are we? 1,000, million, billion, trillion. A 1 in 151 trillion chance of actually, those are rookie numbers, a 1 in 151 trillion chance of guessing that cookie. They're going to have to make a lot of HTTP requests before they actually hit one of these. Statistically speaking, like, they can't even get a reasonable chance until some billions. And at that point, like, the server's going to, hopefully some sysadmin on that server realizes something's up and says, you know what, you've had enough, buddy. Time to go home. And still possible with these numbers. That's why 2 to the 80 is a lower bound. Really, you're going to have, like, I don't know, give it 2 to 200. It takes almost no effort for you to go higher. Just go higher. When it's just a constant in your code, you say, oh, instead of 80, let me punch in 200. Done. Like, just do this. Nobody is ever going to guess one of those. So you can trust those tokens. You can trust that. I mean, it's reasonable to trust that token because nobody could just randomly generate those tokens. If somebody has that token, it either is the authenticated user or that authenticated user was attacked in such a way that if you were to protect against that attack, you're also restricting the legitimate user. So we can always go back to just give me your username and password on every request and force the human being involved to use their memory and punch in that password. Aside from doing that, like, you don't want to ruin the user experience, so we're going to trust these tokens to maintain that user experience. Your HTTP requests are just built different. So anybody who possesses this token, we're going to treat them as that actual user. How do you know which salt? If the salts are unique, how do you know which salt? Because you're storing that in the table. So just like I mentioned the table schema for tokens, the table schema would be username, hash, salt. So when you say, okay, this person is trying to authenticate is this username, you're going to go to your database and say, give me the hash and salt for this specific username. And then you're going to pull that salt from your database. And what I recommend, I'll do a demo of this on Wednesday. Wednesday's when I'm planning to do this, is I'll demo using the bcrypt library, which actually handles like all of that for you. You do have to do the database storage, but it'll give you one value, which is the hash and salt, in the library, encoded in a way that the library knows exactly what to do with it. So you're going to store your password as just one, your hash and salt as one value. But please use bcrypt for that. If you don't want to wait till Wednesday, just search up bcrypt, and like the most common use case, I believe, is authentication with this, like that. So they'll have examples like right up front in the documentation. They should, at least. How do you confirm salts are unique? You don't. And the salts being unique, it doesn't matter if two users have the same salt. Bcrypt is the best. Yeah, the salts don't have to be unique. Like, these tokens have to be unique. If you want to add an extra step, if you're worried about token collisions, you can add an extra step. I would just bump up the entropy and just, I don't know, hope. But like when it's 10 to the 60, like the last one that we saw when we have 2 to the 200, I'm pretty comfortable that there won't be hash collisions, token collisions. But if you do want to generate your tokens deterministically in a way that you're going to avoid collisions, that would be helpful. Because if you have a token collision, things will break. Like if I were running Google or any app with, I don't know, over 10,000 users, 100,000 users, I would want to make sure my tokens don't collide. But salts colliding, not a big deal. But these are sensitive. These are as sensitive as passwords. These tokens, if somebody has your token, they effectively are you. So we can add extra layers of security. I would suggest this one. I'm not requiring it for the homework. But when you have a database full of username to token and token to username, however you want to look at it, that database is as sensitive as a database of passwords. Maybe not quite as sensitive, but because you can just invalidate all the tokens. But anybody with a token can masquerade as that particular user, so you want to protect that data. That's very sensitive data you're storing. So one solution to this is just hash the tokens. You don't need a salt here. We don't gain the extra value of a salt. We kind of do, because if you're worried about rainbow table attacks. But it's not really necessary because these... Oh, no, you can't do a rainbow... What am I even thinking? Can't do a rainbow table attack on the... No, because we're hashing. When we're hashing. Yeah. So if you're worried about rainbow table attacks, you can add salts. Nobody's going to stop you. But it's not quite necessary because the entropy of the tokens is so high that that the attacker's not really going to have... like, their rainbow tables won't be built for something with that high of entropy. When they take a hash and apply their function to turn it into the next guess, those functions aren't going to be looking for these tokens. So they would have to build a rainbow table specific for somebody doing this with tokens, which, who knows, maybe they have. Maybe you want to salt them. It's not that hard to salt them, so it can't hurt. But that way, somebody attacks this database, they just see a bunch of hashes. They can't do much with that. When a user supplies a token and a cookie, you hash it and then look it up in the database. Salted cookies. Oh. For only being 6 slides, I have a lot of... Maybe this should just be more slides. I have so much to talk about on each slide. So now our new authentication schema is after somebody has registered, we're gonna receive a request and we're gonna check for the cookie. We're gonna check for a cookie containing the token that we're expecting. If the request has that token, we're gonna look it up in the database, hash it if we're using a hashing hashing approach, salt it and then hash it if we were using that approach. But whatever you did for login, do the same thing here. Look it up in your database and find the username associated with that token. If there is no username associated with this token, do not authenticate the user. This is not a valid, legitimate user. Just say 403, not something. You're not allowed to do that. Don't let them access sensitive information for any particular user. If the user is found with the username, then we're going to say, okay, you possess this token. We're going to trust that you are the user who logged in, and you are the user that we gave this token to. And at that point in time, your username and password matched, so we will treat you as though you are that person. And then and then whatever content you're looking. Maybe they're trying to post upload an image or something, and we want that image to be associated with that user. Then we're going to handle that request as that particular user. For your homework, you have to display some HTML with their username in it as more of a proof of concept that, hey, look, we know who you are because you have that token. Here's your username as a proof of concept. For your project, that will be a lot of content specific to that user, their DM notifications and things like that. You'll have associated with that user because they have that cookie. And even on your WebSocket request, your WebSocket start as HTTP request. You have access to that token when you establish the socket connection. So when the socket is connected, when you're going through the handshake, you say, oh, you provided that cookie. So this WebSocket connection, I'm going to treat all of the traffic over this as though it were you. And then that person receives a DM. You go to the socket connection for that particular user because when they did the handshake, they had that token in a cookie. And then you send them that information. Here you go. Here's your information for over your WebSocket that has been authenticated with your token. If they don't have any cookies set or it's invalid, you can redirect them to the login page is usually an effective strategy. But if your login page is just part of your app, you have a big single page app, just display a message and say, hey, try again. Or log in, rather. Never trust your users. Ever, ever, ever. So what I want to do is do a demo. I'm going to go to this site, Congregate, which unfortunately does not allow uploads anymore. It's kind of a dying site these days. But I'm going to go to this site in two different browsers. Here I'm logged in as Hartloff.jl. Here I'm also logged in as Hartloff.jl. Forgot to refresh. And you can see all these cookies that we have. Let me cover up all this crap. Let's get the technical stuff. We're not interested in games, right? And let's go to the cookies. We have all these cookies stored, which are being sent on each request. And we can go to the network tab and refresh. Headers, and we can see all those. Oh, it's setting a whole bunch of cookies, or one cookie rather. You can't set multiple cookies. It's just a really long cookie. So talking about entropy, that's a lot of entropy. You're not randomly guessing that ever. Like somebody went a little overboard with this one, to be honest. Somebody went a little overboard there. And we can see our directives path. So any congregate page or subpage, any path on this site, this cookie is going to be sent. And HTTP only, so we don't want people reading this in JavaScript, this cookie. And then all the cookies, all the values being sent in my cookie header, all separated by semicolons. So we can see all that. A lot of cookies. Modern sites use a lot of cookies. Not all of them set by Congregate, which when I was playing with this, interesting thing, I actually get different tracking on different browsers. This is Chrome on the right, and this is Opera on the left. And I think possibly Opera is blocking a lot of these, just with what I have installed. But you can see a few places. Google always has their hands on everything. Double click, whatever this is, Lijit, Lijit is an ad serving domain. Surprise, surprise, it's ads. It's always ads. Ads. Scorecard research and our data. A lot of people want your data. Twitter's in there. And a lot more over on Chrome. ADN and NXS. This is probably just my settings. I believe in Opera I block third-party cookies, which, I don't know, a lot of them still get through. But you can see a lot of tracking going on through the cookies. What I want to talk about today is a few things. First of all, if you want to clear all your cookies, clear. Now I don't have any cookies. Clear. Now I don't have any cookies on this site. I'm going to revisit the site. Actually, let me go to network. Should be interesting. We get our ridiculous number of requests because this is a modern site. And we get several set cookies. Remember we said you can have multiple set cookie headers. We have multiple set cookie headers to set those cookies. Then somewhere in this garbled mess of a modern web page load, there's going to be more set cookie requests. A quick note, this doesn't matter too much in these examples, but we're not using, this site is not using, well, I'll get there, is not using HTTP 1.0, 1.1. This request is, but a lot of them are using H2. So if you are wondering, if you have a really keen eye, you're really observant, and you said, wait a minute, I thought the S and C were capital in set cookie, you're right, you are absolutely correct. But this is for a different version of HTTP, not HTTP 1.1. So if you're wondering why aren't all these capital? I thought content type had a capital C and capital T. You're completely correct. This is just a different version of HTTP. Anyway, back on track. We reload the page and look at how many cookies came back. They immediately came back. Most of these are tokens with enough entropy that they're unique. And let's go to, I guess, Notepad. And it cuts these off. So let's see how much, oh, of course you're not gonna. Does it actually end in ... I find that hard to believe. But, and as you can see, these are pretty long strings, uppercase and lowercase. Oh, and numbers. Did we just happen to only get one number there? All right, anyway, let's go on to the main event here. Here, I'm logged in. Here I'm not logged in, and I just cleared all my cookies. These are two different browsers. This is Chrome, this is Opera. They're not going to share data across between each other. So I have no way to communicate between these browsers. If I go to my application, go to all my cookies, I'm going to see all these cookies. I have them sorted by domain, and I'm interested in the congregate cookies. The congregate cookies there. Let's refresh. I think I get more cookies on a refresh. A few more. Look, Yahoo's in there too. It's crazy how all the big players they're just everywhere. And there's one important cookie right here, congregate session. These are of course going to be different values in my across my browsers. And if I take this cookie, a ridiculously long cookie, because somebody at Congregate is either very security aware, just very paranoid, whatever the reason, we have a ridiculously long token. Maybe they didn't feel like figuring out token collision, so they're just like, let's make them so big that we'll never have a token collision. I'm going to copy this. I'm going to paste this. I'm going to refresh. And now I'm logged in. I didn't have to type in any password. I didn't have to do anything fancy. All I had to do was steal this cookie. Once I have this cookie, and here, if you want to screenshot that and log in as me on Congregate, go ahead. Good luck typing all that and not making a single typo. And but with that token, anybody with that token can be me. They can go to Congregate and just be me. So that's what the attacker has to steal. If they can steal that token, then they can log in as me without knowing my password. So if they don't want to attack my password, they can just grab my cookie. And if they can get this cookie, then they're in. This cookie actually doesn't have the secure flag set. So for being so paranoid and having these huge, massive length tokens, the devs over there didn't bother setting the secure directive for some reason. Don't ask me why. They did use it here, so they're aware of what it is. Unless this was set by a library, it's possible. But they didn't set secure, and hopefully they redirect traffic at least. HTTP. Nope, there's my cookie. There's my cookie sent unencrypted over the internet. Okay, so that's a bad developer. No cookie for that developer. Whatever entire team let that slip by them. This should be set for all your authentication cookies, and of course the HTTP only. They do have that one. So if I go to the console and I do document.cookie, I'm not going to get that big long cookie that token here. So anybody attacking with a JavaScript attack, they're not going to have much luck. But since the security directive isn't set, if somebody accidentally goes to http congregate.com, on that request that gets the 301, the redirect to the secure site, that request has that token in plain text. So I'm sitting in a lecture hall. I want to get my friend's token. I have Wireshark running, sniffing packets out of the air. I'm looking at all the Wi-Fi traffic, and I say, hey, check out this new game I found on Congregate, and I intentionally don't include the S. I just say http://congregate.com/ some Family Guy game, the Family Guy game that they keep promoting. My friend in the lecture hall clicks that. Doop. I grab the packet out of the air. I got their token. I log in as them. Easy day. That's an easy hack. Because they didn't write that one word secure at the end of their cookie. Don't be like that. For the homework, you don't have to do that because obviously we don't have encryption set up for the homework servers. For your project, we might not either. But when you're out there in the real world and you have real live users, not just dev users testing your site, set that secure flag. For the love of all that is holy, set that secure flag. If we go to, I wonder where else I'm logged in. I need someplace else where I'm logged in that I also just don't care about. Like if somebody attacks my Congregate account, I just don't care. I don't have any credit cards linked to it. I never bought Kong coins. What do they even call them? Yeah, I don't know. I don't have another example. But let's just go somewhere where I'm not logged in. And you know what? Let's not ad-lib one. So I gave enough commentary that even just that, I didn't think that would fill up a lecture. But I do kind of interested now in doing the next demo. You know what? We got time tomorrow too, or Wednesday rather. Let me not rush it. But that's authentication tokens. They're set in cookies. Those cookies need to be protected. Ideally with the secure site. I would like same site strict as well for my flavor, for my taste. Let me just check. Let me just make sure. I don't think I'm logged in. to any Google apps. All right, I'm not logged in anyway. But I think this is gonna take too long. But I wanted to make sure that they're secure and HTTP only. Yeah, they're probably gonna do every cookie is secure, aren't they? Anyway, let's end the lecture there. And we'll be back on Wednesday with some more demos. I'll demo bcrypt, and I'll demo attacking a hash that has been salted. Is the one that I was going to try to rush right now. I'll save that for Wednesday.